Welcome to Healthcare Workflow Process Improvement, Process Mapping. This is Lecture F, Unified Modeling Language, UML. The objective for this lecture is read and interpret UML class, activity, and state diagrams. Upon the completion of Lecture F, you should be able to understand the purpose, symbols, and conventions for UML class, activity, and state machine diagrams, and read and interpret the UML diagrams. There are entire certifications in UML and object-oriented design. It would be impossible to cover the entirety of UML in this lecture. Similarly, it would be impossible to impart skills to create UML diagram sets. We use this lecture to introduce 3 UML diagrams most relevant to workflow analysis and process redesign, and refer the interested student to the publicly available reading and training on UML and object-oriented design. Each of the methods for diagramming a process covers different process aspects. Unified Modeling Language, UML, has diagrams to represent each of the process aspects that we are interested in for process analysis and redesign. These include use case diagrams that represent the context in which the system operates, process and data flow steps, information content, any information transformations that occur or should occur, the order or sequence of the steps involved in the process, including flow control and state, and the roles of the persons completing the steps in the process. There are 13 different types of UML diagrams. We will cover 3 of them here. Unified Modeling Language is a standard developed and maintained by the Object Management Group, OMG. The first UML standard, UML1, was released in 1997. Watson, 2010. The Object Management Group states, the rationale behind the creation of the UML standard was that visual software modeling was plagued by the incompatibility of different notations created by different modeling gurus. The absence of a standardized notation deterred potential users, and as an inevitable result, the modeling tools market was tiny and fragmented. Watson, 2010. UML is for software design and development, not workflow or process representation. However, software development necessitates process and workflow analysis and representation. Thus, because they represent the same information, UML diagrams are sometimes used on workflow process improvement. Further, UML adapts and incorporates notations that existed in the early 1990s. For example, ISO 5807 flowcharts, Jordan, Gaines-Sarson, entity relationship diagrams. UML notation was developed to support visual modeling in the development of software, and later to support using the models to automate software development. UML provides different diagram types that represent aspects of computer software and system context. For example, functionality, data content, and data movement, not physical process steps. Many IT professionals are trained in UML. Thus, workflow analysts may encounter UML diagrams in practice. We present in this module how to read UML diagrams rather than detailed training on how to create UML models. The 13 UML diagrams fall into 3 categories. Structure diagrams, of which there are 6 types, represent static aspects of system structure. One structure diagram, the UML class diagram, is covered here. Behavior diagrams, of which there are 3 types, represent dynamic aspects of systems. Of these, 2 diagrams, the UML activity diagram and the UML state machine diagram, are covered here. Interaction diagrams, of which there are 4 types, represent detailed behavior. Interaction diagrams are not covered here. A class diagram is a model of the information stored in a system and, in many ways, is analogous to the ER diagram covered in a previous lecture. A class diagram shows static information content. For example, data that are collected or used in patient care. Data collected and used in the diagnosis of tuberculosis are shown on the diagram in the slide. Class diagrams show the data in boxes and the relationships between the data, called associations. Like entity relationship diagrams, class diagrams also show the minimum and maximum times an instance of one class can be related to an instance of another class, called cardinality and modality of the relationships. A class, shown by a box, represents the information collected, generated by, or used in a process. An association, shown by a line, represents relationships between the information. Where an entity relationship diagram shows only the number of times data can be related, class diagrams employ more types of relationships, including aggregation, composition, and inheritance, that are designated by different arrowheads. Navigability, i.e., direction of the relationship, is shown by an arrowhead. Cardinality and modality of the association are shown by numbers on the lines. It is easier to see these in this larger view of the class diagram shown than of the one shown on slide 9. In UML, the associations use different types of arrows. The black-filled diamond signifies composition. For example, a package of skin tag removal supplies is composed of a set of tweezers, a pair of scissors, and some gauze. In this case, the black diamond would be on or attached to the skin tag removal supplies box. An open diamond, not shown on the slide, signifies aggregation. In aggregation, the aggregate class, the box to which the open or white diamond is touching, is in some ways the whole, with the class on the other end of the association being some part of that whole. The open triangle arrows signify inheritance. Inheritance means that one box, also called a class in UML, receives its properties from another. For example, boxes for patient and pediatric patient may have an inheritance association because all of the information that applies to a patient would also apply to a pediatric patient. In this case, the open arrow would be attached to the patient class. A dependency, not shown on the diagram, signifies a relationship that is less direct or not directly dependent. Dependencies are shown with dotted lines. Similar to a flowchart, an activity diagram shows movement of either tasks, steps, or movement of information. In UML parlance, this is called the dynamic aspect of a process, or simply behavior, as opposed to class diagrams that show the static aspects. Although activity diagrams have a significant number of features in common with flowcharts, the symbol set is smaller. Activity diagrams focus on the movement rather than using symbols to differentiate types of data or types of task steps, etc. An activity, shown by a long rectangle with rounded corners, is a task that is performed either by a person or a computer system. Motion and direction, shown by lines with arrowheads, indicate the flow of the process or information. Branch points in a process, shown by either a diamond or a heavy horizontal line, indicate when more than one option or path exists, by which the process can proceed or the information can flow. The start and stop of a process or information flow are shown by circles. In this simplified activity diagram example, the process starts when a patient calls to schedule an office visit. The receptionist answers and attempts to schedule the appointment. If a mutually convenient time is found, the appointment is scheduled. If not, the process ends. When the scheduled date arrives, the patient attends the visit or not. The process is complete when the office visit is over. A state machine diagram, also called state diagram, shows the different states, also called statuses, allowed as something moves through a process. For example, as information is processed by a system. For example, a prescription may have any of the following statuses: requested by patient, authorized by provider, sent to pharmacy, filled, or not filled. These would be examples of states or statuses that an e-prescription may have. In real-life applications, something like a prescription or other order may have 10, 20, or more states. State diagram symbols are simply rectangles and lines and arrows that denote transition. This simplified state diagram example corresponds to the previous activity diagram example. The process starts when a patient calls to schedule an office visit. The receptionist answers and attempts to schedule the appointment. While trying to find a mutually convenient time, candidate time slots are marked as tentative. When a time slot that will work for both the patient and the practice is found, the appointment is scheduled. That state remains until the appointment has arrived. The patient has arrived. At the end of the time slot, visits that have not been arrived are marked as missed. If the time slot has been marked as arrived, it is given a status of complete when the form is entered, i.e., when the patient is leaving. Importantly, the diagram shows valid transitions. For example, according to the diagram example, a scheduled slot can go to states of arrived or missed, but a scheduled time slot cannot go directly to a status of complete. UML is an international standard and is maintained by the OMG. The standard is freely available from the OMG website. In this lecture, we provided a brief overview of Unified Modeling Language, UML class, activity, and state machine diagrams. We covered the purpose, symbols, and salient conventions for each of the diagrams. This is the final lecture of 6 in the Process Mapping unit. You should now be able to understand the purpose, symbols, and conventions for UML class, activity, and state machine diagrams, and read and interpret the UML diagrams.